Welcome! Today we're gonna check out how to set up the Raspberry Pi Pico C++ SDK. Let's get started. First, we have to install some required dependencies. For this, I'm gonna make use of the Brew package manager, which is pretty widely used across macOS, but if you're not familiar with it, you can just go to brew.sh and follow the instructions how to install it. That's also what I'm gonna do, so I'm just gonna copy the URL here, spin up a terminal and execute it. After the installation has finished, we can use Brew to install all our required dependencies. For this we can type brew install and then we list all our dependencies. So my terminal already recommends all the required dependencies because of course I did it before. So we're gonna need make and CMake, which are two build tools that are required to build the source code of the Pico SDK. We need Git to actually fetch the sources, GCC ARM embedded, which is a cross-compiler to compile our code for our microcontroller, and libUSB to enable some generic USB functionality. Hit return and it starts downloading our dependencies. After everything has been installed, we can download the Pico SDK source code from GitHub. For this, we just go to Google and search for the C++ SDK. And we choose the GitHub link to the repository. We click the code button and copy the HTTPS URL. We can directly clone it into our workspace, but I usually like to keep it in a separate folder, so that's what I'm gonna do. Just create a separate folder, switch into it, and then execute git clone with our copied URL. And it will clone it into the Pico-SDK folder, which is now here. So we can switch into that and see we have all the stuff from the GitHub repository. But if we take a look at the GitHub repository again, we can see that some dependencies in the library folder are actually managed as Git submodules. And the git clone command doesn't download them by default, so we still have to initialize those. So we execute git submodule update init, and it will download all the referenced repositories in the lib folder. Alright, now all the sub-repositories are finished. We can switch back to our workspace and we're actually ready to create our own project. So I'll just create a new folder, which I'm gonna call my project. And of course, we're gonna base it on some existing project, which will be the Blink example. So for a moment, I'm gonna change back to the Pico directory, fire up Google again and search for the Raspberry Pi Pico examples repository, which is right here. And we're also gonna download it. Copy the HTTPS URL and execute git clone. After that is done, we can check out the content of the repository and see that it comes with quite a lot of examples. But we will make use of the Blink example. If you have a regular Raspberry Pi Pico, If you have a Wi-Fi enabled board, make sure to choose the example from the Pico_W directory, which is what I'm gonna use because I have a Wi-Fi enabled board. I'm gonna change into the Blink example, and we're just gonna copy the C file. So one more directory, and I'll name it Blink C. Now I'm gonna switch into our project folder where we have our example program, and we're almost ready to build it. But to actually build our project, we need a CMake file. An example of a CMake file to make a project work can be found on my GitHub account, which I will link in the video description. So what I'm gonna do is I'll just copy that and create that file locally in the root of our project. So now our project contains our CMake file and our Blink C. Let's quickly have a look at the CMake file to see what it actually does. So first it includes another CMake file, which we actually still need to copy from the examples repository, which just sets up the whole SDK, excuse me. Yeah, it sets like the C standard, defines the actual source files we have, and yeah, enables some additional libraries that the project is gonna be linked against, where we already have like one important thing you have to do. If you have the board with Wi-Fi, with the Wi-Fi chip, you have to uncomment those lines, because this is the library that handles the code for that chip. So I'm actually gonna do that. And then we still need to copy the CMake file from the examples repository, which is in Pico examples, pico_SDK_import.cmake. Copy it to our project. Now we should have those files in the root of our project. And now, for real, we have everything what we actually need to build it. So, at the root of our project, we create a new folder called build and change into it. Then we have to export two environment variables that are used during the build, which the first one is our path to the Pico SDK, like this, and the second one is the actual board we have. If you have the regular board, it is just Pico. If it is the board with the Wi-Fi chip, it's Pico_W. So we export those variables, and then we can run CMake with the parent directory. And it will create all the make files that we need for our actual build. So if we take a look what's actually here, we see that it has created a bunch of stuff, which we don't really have to concern us too much. Everything we need to do now is execute make, and it should build our binary. After the compilation has finished, we should have a blink.uf2 file in our build directory, which we have here. So everything worked as expected. And now we can connect our Raspberry Pi Pico to our PC. And for this, we're gonna hold down the boot select button, which is a white button next to the micro USB connector. Hold it down and connect the micro USB cable. Then you can let go and it should show up as a mass storage device in Finder. So here we can see it is connected as a mass storage device. And now we can just drag and drop our binary onto this device and it will execute our new code. Go to our projects, find our binary and just drag it in here. After it has uploaded our binary, the Raspberry Pi Pico has disconnected automatically. This is totally normal. It just means that the board restarted and it is now executing our custom binary. If you take a look at the onboard LED, it should now blink, which means you have successfully uploaded your first program. Congratulations! Thanks for sticking around until the end of the video. If you've enjoyed this tutorial, make sure to watch it for the next episode, where we take a look how we can flash the Raspberry Pi Pico board without manually disconnecting and reconnecting it all the time. So have a great day and see you next time.